Yeah, so I'm here to talk about Webhooks at scale. I'm going to talk a little bit about my experience dealing with Webhooks specifically and what we build and now that's relevant. So quick intro, I'm Alex Salm, French-Canadian. To keep it simple, just call me Alex. So I'm the co-founder and CEO of Hookdeck. At Hookdeck specifically, we build an event gateway, but I'm going to be talking a little bit about that later. But just to give you an idea, we sit in between the providers that you integrate with that send webhooks or events to your application and your own servers and services. Specifically, we've handled over 1 billion webhooks by now. And so we know a thing or two about how things can get ugly dealing with webhooks. So the first point I want to make is when we talk about webhooks, for most people, we think about HTTP post requests, we think about HMAC signatures and kind of like the requirements around the transport itself. But behind every webhook hides an event, and really working with webhook is working with event-driven architecture. And so I have this like saying where I say webhooks are the gateway drug for event-driven architecture. And what we see in a lot of teams, they don't necessarily have event-driven pipelines built out using whatever message bus like Kafka or whatever, you name it. And their first exposure to event-driven programming paradigm and the architecture considerations are from working with webhooks. So why are webhooks hard? There's three main kind of like categories, three main reasons. So the first one is because it's exposure to event-driven paradigm, event-driven programming paradigm. And so therefore, there's the same considerations that you would get in any other event-driven systems. And so there we're talking about out of order, duplicates, queuing, dead letter queues, alerting, back pressure management, troubleshooting, retries, all those sorts of issues. Then it's a fundamental difference with normal event-driven systems because you don't control the publisher. Usually when you work with the message bus, whatever you've worked with like Redis or RabbitMQ or SQS or PubSub, whatever, you control the publisher. You run a service that publishes to those, and you get control over how many are we publishing, what is the scale of those services, and so on. And you also control the downstream consumers, right? The thing that's particular with webhook specifically is that you're basically acknowledging that it is a webhook because it's coming from someone that you don't control, right? It's coming from Stripe, it's coming from Paddle, it's coming from PayPal, it's coming from Twilio, whatever, you name it. And you don't get to go to Stripe and be like, yo guys, my server's down. So I don't want any of your webhooks right now, right? You kind of just have to suck it up. And so that is one of the fundamental constraints of building for webhooks. And then the last part is that you're not just integrating with Stripe. You're sitting with Stripe, you're integrating with Twilio and all the other ones that I name, and they're gonna have different timeouts, different retry logic, different signatures, different guarantees around ordering or around guaranteed delivery and so on. And so when you're building, you're not building for the best one. You're not building for Stripe webhooks, you're building for the worst one, right? You're building around the constraint of Twilio that's gonna retry a single time after 30 seconds, right? And so most often what we see nowadays is that you're no longer integrating just with one. You're integrating with multiple at once, and you need to take the design considerations for each of the provider that you integrate with. So I want to run you through some of the problems and some of the solutions that we've seen in the wild, right? Like obviously I have like 20, 25 minutes here. I'm probably going to run over because that's just how it goes. And so I can't like go in depth on all those things, but I want to like try to have a lay of the land of what are the things that you need to be thinking about, right? And afterward, come talk to me and we'll get nerdy. So the first thing I want to talk about is like the event-driven problems. And so those are out of order and at least once. There's a bunch of like kind of subset issues to that. But the biggest thing is that you can't trust the order of the webhooks that you get with no providers. The fact that those systems are built on an at least once guarantee means that not only is it a risk that you get duplicates, if you're operating at a big enough scale, you will get duplicates, right? And so you can't build around the assumption that, whatever, it's not gonna happen to me. It will for sure happen. And so your system needs to account for that. I'll like an example here. Let's say you get like a subscription updated, right, from Stripe. And so your code tries to put that in, update the subscription database, but the subscription created occurred after, right? And so now you're going to run into an error because that record doesn't exist in the database. Same thing if the created happens after, tries to insert a new row in the database. Well, now potentially you've already inserted it from the updated, and you run into a parent key conflict or like what have you, right? So just a couple of examples. But before we can talk about solutions there's one concept, and there's this one thing everyone in this room, if they want to build event-driven architectures, needs to understand to their bones, is the concept of idempotency. And so there's this one interview question I ask every single engineer. It sounds kind of pedantic, but it's like, what's the difference between an HTTP post request and an HTTP put request? All right? Most people will tell me, oh, well, use post to like create a resource, and you'll use put to update a resource. Yeah, but that's not the real reason. That's just a manifestation of idempotency. And so what we mean by idempotency is that when you do the same action multiple times, you get exactly the same result, right? The thing in HTTP and REST world that you're kind of for sure used to is that you get to decide if something is idempotent or not. You get to decide if you're using post or if you're using put, right? And you get to tell the user, hey, by the way, if you call this post endpoint multiple times, you're going to get multiple resources created, right? In event-driven world and with webhooks, you don't get to choose. Everything always has to be idempotent, point blank, regardless of what it does, right? Except if you don't care that happens multiple times, but I guess you could define that as idempotent in some ways. But assuming there is some consequence, like you're sending an email to a customer, well, you don't want to do that twice. Or if you're processing a transaction and you're refunding the customer twice, right? Like that sort of stuff can't happen. And you don't get to decide whether or not it can or not happen. You need to design around that consideration. So I'm going to share 3 ways to deal with idempotency. I can't like cover all the strategies, and no one strategy fits every use case. You have to mix and match depending on what are the specific design criteria for your application. So the first way is to fetch before processing. And before I get into like the specifics of that, Stripe 2 weeks ago released Stripe 10 events, which is a new payload format for their webhooks, where instead of sending you all the webhook data, they just send you IDs. And so they tell you, hey, this subscription was updated, but I don't tell you anything about the subscription, right? The reason why they're doing that is because they know people are doing this. They're fetching before they're processing. And so what that means is that they get the webhook. Instead of doing anything with the data in the webhook, they just go fetch the API and ask Stripe like, okay, this subscription, give me the data for it. And the advantage of that is now you don't really have to care about order because you use the notification just as a mean of showing something happened. And you always refresh the data from like the data source. Now that has constraints though, because you have API rate limits, right? And so you might be fetching from Stripe or from Twilio or whatever when you're trying to populate that data too often that you run into rate limits. And so it scales only to some extent. And it also only works if what you care about is just the state of the event. So it's in the state of the object in the case where you're doing like record syncing, for instance. The second strategy is to upsert by date. And so the idea here is to say you have a transactionally ACID compliant upsert strategy. In this case here, I have an example using Postgres, where you can natively do a upsert in a single SQL query. And so the idea here is that like you will update an object, either create or update the object, regardless if the event that you got was for an update or a create, but you're also going to do it conditionally based on date, right? And so the idea is basically instead of reordering, you're ignoring data that you're getting that is older than the data that you've already processed, right? So in the case of subscription, if I get the updated and then the created, my update is going to insert the row in the database. My create is also going to try to insert the row, but the date is going to be smaller, well, before the record I already have, and so it's going to do nothing. And the thing that's great after that is based on the result of that query, you can compare the dates to know whether or not you did actually upsert and do your logic based on that. So if a customer subscribed and you want to send an email, for instance, you can do it only if the upsert was for a create, right? And so basically if the dates don't match, because then you know that, well, if the dates don't match, you know it was an update. If they do match, you know it was a create. And so that's great if you are dealing with higher throughput, for instance, or API rate limit constraint. If you need to know that the data is the most recent, right? And so like this, the fact that it's different than the one that you had before matters. But there's a limitation that you must be keeping track of records. The big warning I have here, this needs to be transactional. If you're doing that in 2 different queries that are not transactional, regardless of what underlying storage engine that you're using, this is not going to work because you're going to run into race conditions. Last one is tracking the processing state. That is especially relevant in the context where you're not actually keeping the records and you have nothing to compare against. And so the idea here, I have a kind of like Node.js example, is that you're using a separate storage that needs to be async compliant, once again, to track whether or not for that specific webhook, you already processed it, you're processing it, or you've never seen it before. In which case, if you've never seen it before, you process it. If you are processing it, that is very important, you want to return an error, right? Because you don't know if the event you're currently processing will finish processing successfully. And so if it doesn't, you want Stripe in this case, or whatever system that you're using to queue those webhook to know that a retry is going to be needed, right? Because you only want to return in this case, 200 in the example I have, if you know for a fact that you've processed it successfully, right? So that's it for idempotency. I'm going to move on to a next topic that has a lot more to do with architecture. So one big design criteria, I kind of had the example of like your server being down and you not being able to tell Stripe to stop sending you events. The other thing that we see very often when it comes to webhooks is that there's going to be very bursty traffic pattern. And so you're going to have instances, for instance, where you do a bulk update of all your customers because you're adding a new tag or whatever. And you're not necessarily going to consider the side effects of like each one of those updates is going to generate a customer updated webhook, right? And so lesson learned in, what was it, 2018, I want to say. I was on I'm probably a little bit early in that. Anyway, I was on my first software engineering job. And a couple of months in, I took down the production API by sending a new email campaign that was relying on customer IO webhooks, right? And so those are kind of like the hard-learned lesson, sending email to half a million people. Our server needed to generate dynamic content for those emails. And so we got a webhook for each one of the emails that was going to go out. Took down the production server on a Friday night. And the lead backend developer wasn't really happy with me that night. One thing that you'll notice also is that the way that capacity and timeout relate to each other is not linear. And so that means if you go ever slightly over your capacity, your response time is going to skyrocket, right? And that compounds with retries and an exponential backoff retries. Because the other thing that you'll see is, like, for instance, if you fail, Stripe is going to retry 30 seconds later. Well, now guess what? In 30 seconds, you're getting the retry and any new webhook that you were also supposed to get, right? And so that problem compounds. And then the back off on the retries will build up. And then at some point, you're going to end up with events that are going to be retried in 6 hours, right? Which now becomes a data freshness issue. And so the point is, like, you need to be able to deal with those spikes. And there's, in our experience, virtually no system that has hard constraints on its scalability that will be able to not time out. And so you need to build a system in such a way, like I'm getting at it myself in the solution, you need to build the system in such a way where it's completely decoupled from any of the processing that you do so that it can scale to any of the volume that you get, right? Here I have like an example that we have from like our website. It's like what Hookdeck replaces, but like the components in there are still relevant. So the idea is that you want your ingestion worker, whatever receives those requests, to be decoupled from the processing and queue all of the events that you get and then process from the queue itself, right? One thing that people will often tell me is like, okay, but Alex, like I need to filter. Like for instance, like I'm building a Stripe app and I'm getting webhooks from everyone that ever installed my app. And even if they uninstalled the app, I'm still getting webhooks. And so it's like, obviously you don't want to queue all of that. And so you need to like verify whether or not like that user is a customer, right, for that webhook. But the way that you want to do this is basically on like a optimistic design where you try to figure out if it's a customer or not. And if you can't figure it out, then you assume that it is. And you figure it out later, right? And so, for instance, you can have like a caching layer on your ingestion where you're going to have aggressive timeouts of, let's say, like half a second or something on the lookup. And so you're going to try to verify if a customer exists in the KV. If you can't, or the timeout expires on the KV lookup, you're just going to do as if it exists. and whatever is consuming from the queue later will then run that logic again, like for all intents and purposes, right? And so you can kind of like optimistically do it earlier in the process, but you need to make sure that there's nothing where the event volume on the ingestion itself will take down downstream services. Like for instance, if you're running like a Postgres database, like you for sure do not want to be querying Postgres from your services that are receiving those webhooks, because not only will at some point you'll run out of connections, for instance, on Postgres, but it will also cause like starvation issues with other services that you might have using that same database and so on, right? And so isolation is the key at the ingestion if you don't want to time out. Now though, you have, I think we're doing a Q&A at the end. So save your question. Now though, you have another new problem, which is you've put a bunch of stuff in a queue, right? And it doesn't mean that everything you've put in the queue, you're actually able to process. And so the second consideration that you have is how much can you scale based on the amount of things that you put in that queue, and how do you manage back pressure? Back pressure is that concept of in queuing theory, where essentially if you have more than you can process, you accrue delay on how fast you can process it. And so you either need to like increase the throughput on that queue, or you need some other mitigation to deal with the fact that you know you're gonna have a delay. And so there's like best practices around that in terms of understanding very well what your scalability constraints are. So the workers are going to be pulling from those queues. How many requests can they actually process? How many workers can you have working at the same time? What is your baseline operating capacity versus what is your theoretical capacity, right? Because if you end up in a back pressure situation, you want to know what's the maximum you can scale to without your having downstream impact on the other services or having other processing capacity issues. And the last part is you want to instrument that queue. You want to know when there's back pressure. And so there's like usually two metrics that you're looking for in your SQS world or GCP world or whatever. And those are queue depth and max age. So you want to set up alert triggers whenever the messages in the queue are there for longer than a certain amount of time, or there's more than a certain amount of messages in there, right? In Hookdeck, we have this concept where we calculate the kind of the intersection of the two. So how long they're in there versus how fast you're processing. And we give you like an estimate of how long like it will be in the queue. In most other systems, you kind of need to like work that out yourself, right? Okay, next point is that eventually something will fail, right? And so you'll do a bad deploy, server will go down, database will crash, worker will crash, like the list is pretty long. And so in that situation, if you care about data integrity, you basically have two solutions. The first one is to design so that you have processing guarantee. And so that means you need to evaluate every single component in the request chain and make sure that each one of those components is guaranteed to either process or persist if it doesn't process. So in the case of message queues, we have the concept of acknowledgement and NAC. I don't even know, not acknowledgement. I guess I've been saying NAC for the longest time, but I don't even know what it stands for. But the point being, in a message queue, you will guarantee that the message is there as long as you're correctly ACKing or NACking. And so as you evaluate each one of those like components in your request chain, you need to make sure that each one of those are doing the right operations to be able to guarantee processing. And so that's one way. And so when you're operating under that processing guarantee, the way that you're looking at it is basically I'm looking at all my audits. I'm looking at what failed. I'm looking at my delivery queues. And if everything's clean and I know that my chain is correct, then I know I have data integrity, right? But that requires a lot of testing and careful engineering. The second one is reconciliation. So that basically means like screw all this. I'm just going to fetch all the data and resync everything. It doesn't necessarily work for every provider. In the case of Stripe, for instance, they have an events API, which is very convenient for doing that because you can just like reconcile from the events API itself. But in other APIs, you might have to like go and fetch like the individual resources, like the products and the orders and that sort of stuff to be able to reconcile. Usually, it's very tedious to do that. And after like major incidents that cause data integrity issues, it can take like several days to like effectively reconcile, unless you've had like the foresight of building like all the reconciliation logic at a time and so on, right? You know what? For the sake of time, how am I doing on time, Ben? Okay, I'm gonna just get like this one's kind of self-explanatory. I'm just gonna skip over it for the sake of time. Okay. I was like, I was debating cutting the previous one, so like whatever. Okay. The last point I want to make is around auditability, right? So I talked about the alerting for the back pressure. I talked about auditing your system to make sure that like you're hacking or knacking correctly and all that. But the last part is that you don't actually know all the events that you got, and you don't really get visibility into what failed for and why, right? And so like the way that you solve that problem is that you build a centralized event log. And so what we see companies doing, for instance, is that they'll process all the webhooks that they get, right? Kind of like everything we've just been talking about. But they're going to have a second pipeline that also puts all those webhooks, let's say, in like Elasticsearch, for instance, right? And so from Elasticsearch, you'll be able to like go and see out all the historical event they got, search through it, find like specific events. And like when customer support comes in and it's like, hey, Alex, like this specific order, where is it? Like it's not showing up in the 3PL or something, right? You can go back and trace like, okay, yeah, like this is the webhook that was supposed to get processed and kind of like what happened from there. Like, was there a processing failure or like, did we not process it correctly? Now we need to like retry it and that sort of stuff, right? And so that's like a very common pattern. And the last part is like more often than not, people have built their centralized event log, they'll have a critical outage, and then they're like, okay, now we need to replay. And then they're not gonna have built the replay tooling for it. And they're gonna spend a week trying to build the replay tooling that is like sufficiently efficient to replay, let's say the 20 million webhooks that need to be replayed, right? And so depending on the scale that you operate at, you might need to have a little bit of foresight of like, don't wait until the incident happened before you build the replaying tool. Build a replaying tool before it happens, right? So now I want to go on a tangent because everything that like I talked about is just like webhook best practices. It's like best practices we've been building and understanding over the last like 10 years. But there's actually a lot of things that are changing recently. And so I want to highlight some of those things because I think we're going through kind of a fundamental shift on how we're thinking about event interoperability and webhooks and so on. And I want to point those out. So like the first one is event destinations. Actually, you know what? I'll just like quickly mention all three and then we'll deep dive. So there's event destinations, there's event gateways, which what Hookdeck is, but we have competitors. And then there's also just like, we're seeing more investment from the platform and the publishers like Stripe, like Shopify and so on in their own events, right? So for instance, like Stripe just released 10 events that I was talking about. Also, Shopify just released native support for filtering on their webhooks. And for a while, I was working on Hookdeck, and like basically no one in those companies wanted to talk to me. I mean, maybe we were a bit small at that time too, but like the point is for most of these, like Shopify, for instance, did not even have a team working on webhooks, right? Like they did not even have a PM working on it. And now everyone that we talk to, like Stripe, Shopify, Twilio, and so on, all have dedicated teams that are working on improving the experience there, right? So the big two fundamental changes I want to talk about is event destinations. Stripe released in general availability, I want to say a couple of months ago, correct me if I'm wrong, their support for event destinations. In Stripe, you can, basically when you go to register a webhook now, you don't register a webhook, you register an event destination and you choose a type. And the type is either webhooks, right? My point about webhooks being a delivery mechanism at the start, or AWS Event Bridge. So in their case, they're only supporting two. Shopify supports PubSub, Twilio also supports Kinesis. And so what we're seeing is like the big players are pushing a lot of events, are seeing that webhooks have issues, right? A lot of the issues that we've talked about. It doesn't fix all of them, but it does fix some. And so now they're starting to encourage you of saying like, instead of getting this by webhook, getting directly to your message bus. Kind of makes sense, right? Because we remove everything around the ingestion, a lot of security concerns and so on that we've been talking about. Specifically, Hookdeck is the main sponsor of the Event Destination Initiative, which you can find at this website. The Event Destination Initiative takes inspiration from what Stripe is doing and is bringing it as a generalized set of guidelines for the industry as a whole. And so we're working with other companies and partners on defining what those guidelines are. And maybe more importantly, we just released Outpost. Outpost is an open source implementation of event destinations that is available to anyone to use and deploy to support event destinations within their own products, SaaS, and so on, right? So that's just like an example. Like I was super excited when Stripe posted this. It was like the invitation for the beta of event destinations. That was sessions 2 years ago. So they've been working on it for a little while. And then the last thing I want to talk about is event gateways, right? So at the start, I started by saying Hookdeck is an event gateway. We built an event gateway. You guys probably have no idea what an event gateway is, other than the fact that it's like slightly intuitive by the name. But what we're seeing now is more and more competition. There's been products in the market like AWS Event Bridge that I would qualify as an event gateway for a while. And there's Hookdeck and competitors that are building this. And so you're going to see more and more products that are trying to fix this problem and a lot of the problems that we've been talking about. What I'll do is I'll quickly like go through like 3 small demos of how Hookdeck tackles some of those issues, right? But more specifically, like the components of an event gateway. Like when we say an event gateway, what do we mean, right? And so like in my mind, this is a new cloud infrastructure primitive that serves a similar role to what an API gateway has served, but for asynchronous event-driven applications. And there's like 3 core components to that. So component 1 is the ingestion layer that we talked about, along with routing, filtering, and so on. And so basically it's your event management. Like, can I start? Is there a mouse in the middle of the screen? Oh no, it's in the recording. All right, good. All right, let's get through it. Okay, so I pre-recorded this video. I need to narrate over it and I'll try to get the pacing right. All right, so there we go for the first one. Okay, so here I'm using Hookdeck with Terraform. So I'm using the Terraform provider. I'm going to be registering a new source in Hookdeck for my events, which is going to be a Stripe source. I'm then going to use the Terraform provider to register that webhook with Stripe using their API and the source URL that Hookdeck will give me. And then I'm then using the webhook secret that Stripe returns to associate the authentication with that Stripe source. And then I'm going to create 2 destinations, one for my invoices and one for my subscriptions. Those are HTTP endpoints that are going to be processing those events. And I'm going to set a delivery rate on these, right? So like invoices as a 10 concurrent, subscription 10 per minute. And then the last thing, I'm going to wire those things together. So I'll connect my source with my destination, and I'll set filters on it. So in this case, I'm filtering for every event type that starts with invoices dot, and also every invoice where the subtotal is greater than 0, right? And then I'm going to set up my second connection. And I have a retry rule. I'm going to set up my second connection. And then this one is going to be for my subscription. And so it's similar where it's filtering on the customer dot subscription event type. This is what it looks like in the dashboard, right? So you can kind of visually see what we just did in Terraform. So I have my I have Stripe. I can see that the authentication is enabled. There's some historical events on my Stripe source. And then I have my 2 connections with the filters for the customer subscription year. And then the other one for the invoices, right, which is what we add in Terraform. And then the last point is going to be my destinations. And so my destinations are just like the HTTP URL where my server lives and my business logic lives. And Hookdeck itself is serving as my queue, right? Actually, I did faster in the video. Geez, I thought I'd be running behind. Okay, that brings me to the second point, where the second responsibility of Event Gateway, which is message queuing and throughput control. So we're going to the second demo here. We kick off where we were. So in this case, I have my subscription API, which has a limit of 10 per minute, just for the sake of a demo. I can see there's queued events on it. So I'm going to go to all my events. And then from there, I can filter on pending specifically and zoom in on the timeline. So I can see I have a big burst of event that came in, and they're all queued. So that means now I have back pressure. If I go to my issues, I can see there that I have an alert for a new back pressure issue where it says there's more than 1 minute delay on that destination. When I go inside the issue, I can look at the data associated with it. So I can see there's 23 minutes of back pressure that has been accrued, and there's 225 events that are in the backlog. So what I'll do in this case, I'll check the delivery rate. I can see that everything is kind of behaving as expected. I can see the spike in the chart. I'm going to go check my server response time. I can see my server is actually responding pretty quickly, 100 milliseconds right now. And so I know I have the capacity to scale higher. So I'll go back and I'll edit from 10 per minute to 50 per minute to try to deal with some of the back pressure. So as I do that, now I can see that, like, we fast forwarded like a minute here, just so a chart would update. I can see I'm now delivering at 50 per minute, and my back pressure went from 23 minutes to 3 minutes. And as soon as my back pressure is fully recovered, the issue will get resolved. And then the last component is the event log and the retries. So in this case, I'm looking at my historical events that I received. So I can see, like, for instance, I have my subscription here. I can look at the headers, and then I can look at the body. In this case, I'm interested in what customer this was associated with, so I can see the customer year. Now I'm curious what other events I have associated with the same customer. So I'll go and I'll filter for all the requests where the customer ID is in the payload, all right? And so now I can see there's multiples that are associated with it. In this case, there's invoices that actually failed. I have a 500 error. So what I'll do is I'll open it. I actually know what the error was. And so I know now that it's been fixed in the meantime and it's safe to retry. So I'll go in and I'll retry that specific event. Now it's been redelivered. I see that's 200. I'm feeling confident that the problem has been fixed, but I still need to deal with every other errors. So I can go to my issues. I can see that I actually have, I'm going too fast now, like 50 something other errors that are for the same 500. So I can look at the issue, look at the histogram, and then I can like just send them all for retry. So all 52, right? And they're gonna get put back into the queue. So I can see my retry progress and just a second here, my retry is complete, right? So those are like the three main components of Event Gateway and like a deep dive of how specifically we solve that problem. Others are gonna have their own approach and solution. And it's still a category that's, that it remains to be defined in the sense that like that is very much something that's in process, and like that's the kind of like innovation we're working on to like simplify building with webhooks and external event streams.